Hey guys, today we are getting into geometric proofs. I'm sure you've heard lots about geometric proofs, hopefully all good things. A proof itself is just a logical argument to show a statement is true. So proof is a logical argument that shows a statement is true. 4 different types of proofs. There's a 2-column proof. That's what we will be using in this class. There is a paragraph proof. You just basically write your argument in a paragraph form. Then we have an indirect proof. And a flow proof. Your book has some good examples on these, and I would be happy to show you these in class. But we will only be dealing with the 2-column proof, very similar to the algebraic proofs that we started with. Parts of a proof. So just like with your algebraic proofs, we start with our given statement. One thing that we didn't have explicitly listed with our algebraic proof was our prove statement. Our prove statement is where are we going? How do we know what we've proven? You can have a diagram. Lots of times you will have pictures to help depict what it is that you are proving. Statements. So on the left-hand side of your algebraic proof, you had equation. This time it's going to say statements. Those are all of the things that are happening to get us there. And then on the right-hand side, it's still going to say reasons. So these reasons could be definitions, postulates, they can be properties, like our properties of equality that we've talked about, or they can be theorems. So definitions, postulates, properties, theorems, all of those are reasons. So I want you to remember that a proof is a logical argument. You have to convince someone that this is true. So if we know that BC is equal to AB, we need to prove that AC equals AB plus AB. So first off, we have a statement here that says BC equals AB. That's our given statement. So BC equals AB, given. You see that right up here. That's where that comes from. You'll notice the very last statement that we have is our prove statement. So all of those pieces were taken from the beginning. They weren't things that you would need to come up with. And that will always be true. So then this second statement, AC equals AB plus BC, is one that we would have come up with, but being nice here on this first example and helping you out. So AC, that looks like this entire segment length, is equal to the part of the segment plus the other part of the segment. That's a property from Unit 1 that we should remember. That is the segment addition postulate. That tells us when we add up 2 pieces, it equals that larger piece. Now, just like with the algebraic proofs, you want to look and see what is happening from statement 2 to statement 3. And what I noticed right away is that the left-hand side of the equation looks the same. The AB's match up, but BC turned into AB. So we substituted in AB for BC, and we could do that because of our given statement here that says they're equal to each other. So then our final reason, the reason that we were able to get there, is by the substitution property of equality. So that's our first proof. Let's try another one, a little bit longer here. Okay, so we are given that the measure of angle 2 equals the measure of angle 3, and you'll notice by these arc marks that they have marked that in the picture. We are also given that the measure of angle AXD, so AXD, I'm going to double arc that, is equal to the measure of angle AXC. What we want to prove is that the measure of angle 1 equals the measure of angle 4. Notice, they have put the measure of angle AXC equals the measure of angle AXD. That's one of our given statements. So we're going to write the word given. Now, they're helping us out with this second reason that they've given us. It says the angle addition postulate. So remember, just like the segment addition postulate, the angle addition postulate tells you that two smaller angles add up to the bigger angle. So we're looking for the two smaller angles that add up to equal the measure of angle AXD. So if I look, that's this top angle up here, and it looks like angle 1 and angle 2. So the measure of angle 1 plus the measure of angle 2. And again, we have the angle addition postulate as our reason for statement 3. So the measure of angle AXC, that's this bottom angle here, and it looks like it's made up of angle 3 and angle 4. So the measure of angle 3 plus the measure of angle 4 equals the measure of angle AXC. All right, then when I look at statement 4, it says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Well, what I notice is that if I look back at statements 2 and 3, it's taking this second part and this second part and setting them equal to each other, because we know that these two are equal based on this statement up here. So what we've done is substitute those equal things in. So this would be the substitution property of equality. Okay, then kind of out of nowhere, we have the measure of angle 2 equals the measure of angle 3, which doesn't really look like it fits in here, but if you look way back up at the beginning, we have not used this given statement yet. So we have to go back and use it to help us with this proof. So that our reason there then just is given. Given doesn't only have to sit at the very top reason. Okay, so then it tells me for number 6, the substitution property of equality is my reason. So I know that I'm going to substitute something in. So if I look back at statement 4 and compare it to statement 6, they've left this measure of angle 2 blank. So we have the measure of angle 1, we have the measure of angle 3, and we have the measure of angle 4 that match up. If you look at statement 5, it says the measure of angle 2 equals the measure of angle 3. So it's telling you then that instead of the measure of angle 2, we could put the measure of angle 3. We can substitute that in there. Now, what it looks like is I have the measure of angle 3 on both sides. Think about if you were doing an algebra problem. How would you get rid of those things? Because that's what's happening in number 7. We have the measure of angle 1 equals the measure of angle 4. To get rid of those, if they're added on both sides, we're going to subtract. So our last reason is the subtraction property of equality. That's how we got from statement 6 to statement 7. We subtracted the measure of angle 3. We are going to get to practice a whole lot of these in class. So no worries, you'll get very good at mixing these up, putting them in order, those kinds of things. All right, a few more things here. A theorem is a statement that can be proven. We have talked about that, so that should be a review term for you, but always good to cover it again. So theorem 2.1 deals with congruence of segments. The reflexive, symmetric, and transitive all should look like familiar terms to you because we used them for our statements of, or properties of equality. Now we're talking properties of congruence. Same kind of thing though. So the reflexive property says for any segment AB, it's going to be congruent to itself. So AB with the bar, since we're talking congruence, is congruent to itself. AB. The symmetric property tells us that we can switch their places. So if we know that AB is congruent to CD, then we know that CD is congruent to AB. And then the transitive property tells us if we know that AB is congruent to CD and CD is congruent to EF, then we go straight from the beginning to the end. So AB is congruent to EF. Similarly, with the angle congruence, we can say that for any angle A is congruent to angle A. It's congruent to itself. We're talking reflexive. Symmetric, if we know that angle A is congruent to angle B, then we know that angle B is congruent to angle A. Transitive, take out that middle step. Angle A is congruent to angle B is congruent to angle C, then angle A is congruent to angle C. All right, example 3 says name the property illustrated by each statement. So if angle 5 is congruent to angle 3, then angle 3 is congruent to angle 5. What I notice is these have switched places. So they switch places. I know that's symmetric. Now be careful, it's the property of congruence. Use a C there. Or you can write out prop of and use your congruent symbol if you would prefer. All right, then on B it says if angle H is congruent to angle T is congruent to angle B, then angle H is congruent to angle B. So take out that middle stuff. That would be the transitive property. Property of congruence, since I see a congruent symbol. All right, guys, we have lots more to practice on these proofs. If you are stuck on anything, if anything didn't make sense, please come see me. I will see you in class.